because each node can have its own dependencies and requirements. If I filter by installed, you will usually not see many nodes here besides the manager itself. However, I asked Ivo to include a few essential nodes that I use most often. One example is the RG3 custom node, which includes the image comparer node that is very useful for comparing images side by side. Each custom node has a title and a version number. You can switch versions if needed, for example, when an older workflow only works with a specific version of a node. For each node, you also have several actions available. Update only that node, switch the version, temporarily disable it, or uninstall it. You can also see how many individual nodes are included in that custom node package, along with a short description. Some nodes mention possible conflicts with other nodes. If you click on that yellow warning text, you can read more details about those conflicts. These conflicts usually matter only if you use both conflicting nodes in the same workflow. You can also see the author of the node and the number of stars it has on GitHub. Stars are given by users and usually indicate how popular or trusted a project is. Some developers are well known and consistently release high-quality nodes. That said, there have been cases in the past where certain nodes had security issues, so it is still a good idea to be careful. You can also see when the node was last updated. To switch versions, you click the version selector, choose a version from the list, click select, and then follow the steps shown. We will not do that right now. As you remember, every custom node that gets installed ends up in the custom nodes folder. Here you can see all the custom nodes that come with the easy install version at the time of this recording. Now let us install one node as a test, just to see how the process works. Open the manager, go to Custom Nodes Manager, and search for a node called Align. We will use this as a test because it does not require special dependencies, so in theory it should not affect ComfyUI too much. Each node entry has a title. If you click on it, it opens the GitHub page for that node. On GitHub, you can see the code, because every custom node is basically Python code and supporting files. You can also check the Issues tab, where users report problems and sometimes solutions are discussed. If you scroll down, you usually find important information like required ComfyUI versions, Python versions, or other dependencies. These are the dependencies I mentioned earlier, things the developer relied on when creating the node. You also see installation instructions either through the manager, which we are doing now, or manually using commands like git clone, which simply copies the code into the custom nodes folder. Before installing any custom node, it is a good habit to read this information. Some nodes require things your system might not have, and then they will not work. Now let us install this node. Click the Install button. You will be asked to choose a version, so select the latest version. The button changes, and installation begins. When it finishes, you will see a Restart button. ComfyUI needs to restart for the node to become available. Click Restart and confirm. ComfyUI shuts down. You will see the browser trying to reconnect while ComfyUI is restarting. After a few moments, you get a confirmation message. Click Confirm. The node is now installed. If you go back to the manager, open Custom Nodes Manager, and search for the Align node, you will see that it now shows an Uninstall button. If installation had failed, you would see an Import Failed message instead. If you look inside the Custom Nodes folder on disk, you will now see a new folder for this node. It is simply the same code you saw on GitHub, copied locally. This code is what adds new nodes to the ComfyUI interface. If you deleted this folder manually, that would also uninstall the node. However, let us uninstall it properly using the manager. Go back to the manager, click Uninstall, and Confirm. Again, you will be asked to restart ComfyUI. Confirm, wait for the restart, and then confirm the browser reload. Now go back to the Custom Nodes Manager and search for the Align node again. You will see the Install button again, which means the node is no longer installed. If you check the Custom Nodes folder, you will also see that the folder for this node has been removed. This is the basic workflow for installing, updating, and uninstalling custom nodes using the manager. Sometimes when you download a workflow from other people on the internet, you will have missing nodes because they used custom nodes that you do not have installed. When you do not know what nodes they used, you can use the Install Missing Custom Nodes button. This will give you a list of missing nodes and the option to install them. That said, I personally prefer to install nodes manually, so I have full control over what gets installed. That is why I usually include a note node in my workflows, explaining exactly which custom nodes are required. Now let us look at templates. If we open templates, we can see different workflows created by the ComfyUI team. If we filter by image generation workflows and select something like a Z-image turbo text to image workflow, ComfyUI will first tell us that we have missing models. These are the AI models required for the workflow to generate images. Usually, it tells you exactly which folder the model needs to go into and gives you the model name along with a download link or a download button. In this example, you can see it needs a VAE model and a few other models. Once you download those models and place them in the correct folders, the workflow should work, assuming you have enough VRAM to run it. In this case, there are no missing nodes, so let us close this. Now let us go to Menu, then File, then Open, and open a workflow that I know uses missing custom nodes. You will see a message saying the workflow uses custom nodes that are not installed. At first, you might not see any red nodes on the canvas. That is because this workflow uses subgraphs. Subgraphs are basically nodes that contain other nodes inside them. If you have experience with Photoshop, you can think of them like smart objects. When you see an icon with a square and an arrow, you can click it to enter the subgraph. Once inside, you can see the red node that is missing. If we now open the manager and click Install Missing Custom Nodes, ComfyUI detects that node and offers to install it. For many nodes, this works perfectly. However, some nodes, like Nunchaku, require additional dependencies and extra setup. We will talk about those in a future episode. The important thing to know is that for many workflows, install missing custom nodes can quickly fix the problem. Let us close this for now. If we open the manager again, you will also see a Models Manager. This lets you browse and download models by type. Personally, I rarely use this because a model without a workflow is not very useful. In my tutorials and on my Discord server, every workflow comes with notes explaining exactly which models you need and where to put them. The ComfyUI templates also clearly list required models and folders. So let us do a quick recap. Use update comfyui.bat to update only ComfyUI. Use update ComfyUI and nodes.bat to update ComfyUI and all custom nodes. Use update easyinstall.bat to update the easy install system and helper scripts. The update folder exists for users with other ComfyUI versions. The add-ons folder only exists in the easy install version. Inside add-ons, the tools folder includes the version switcher, which lets you downgrade or upgrade ComfyUI if needed. This is useful when a new update breaks a node you rely on. Inside the ComfyUI folder, the Custom Nodes folder contains all installed custom nodes. If you delete a folder from here, you uninstall that node. Sometimes, if a node fails to install correctly, deleting its folder and reinstalling can fix the issue. I know this is a lot of information. Do not worry if it does not all stick right away. Practice, experiment, and come back to this tutorial in a month. You will be surprised how many things suddenly make sense that you missed the first time. Regarding the Tcache node, after a few days, ComfyUI was updated again and the problem was still not fixed. There is now version 8, and even if you downgrade to version 7, it is still not fixed. ComfyUI keeps adding updates, and at some point, some custom nodes will stop working. If that node is not important for you, you can delete it or uninstall it. You can also just disable it from the manager, or drag the Tcache folder into the disabled folder so it is disabled. You can move it back out of the disabled folder anytime you want to try it again. In this chapter, I will try to simplify this complex world of diffusion and AI a little. Do not worry if you do not understand everything that is happening. Like I said before, you do not have to be a mechanic and know all the engine parts to know how to drive a car. This is the core idea behind diffusion image generation. The model does not draw an image all at once. It starts from pure random noise. This noise looks like static on a television. The model then runs a sequence of small refinement steps. At each step, a small amount of noise is removed. Early steps reveal very rough shapes. Later steps reveal clearer forms. Final steps add fine details and texture. Image generation is therefore a gradual process. It goes from noise to less noise to recognizable shapes and finally to a finished image. This slide is a simplified visualization. The real process is more complex. In practice, most diffusion models work in a compressed latent space rather than directly on pixels. A neural network predicts what noise should be removed at each step. Even though the real math is more advanced, this simplified view is enough to understand how diffusion works. It's like sculpting. You start with a rough block and remove material until the shape appears. Or, like a foggy window clearing up step by step, you don't instantly get a sharp scene. It resolves gradually. Let's open ComfyUI, go to Workflows, and from the Getting Started folder, pick Workflow 1, which is the basic text-to-image example. Even if we cannot fully see what is happening inside the K-sampler step by step, we can still get a good idea of the overall process. Remember, what we see here is a simplified representation of what is actually happening under the hood. First, we want a fixed seed. We will see later that each seed starts with different noise. Right now, we are using 35 steps, which is enough for this model to produce a clear image, like this robot. If we change the steps to 1, you can see that the model does not have enough time to remove the noise, so the image is very unclear with these settings. If we add another step, the change is subtle. Adding another one, you can start to see something forming. By step 4, we can almost see a face. We can automate this process to see the changes faster. Double-click on the canvas and add a primitive node. Like you saw in an earlier chapter, we can adapt this node for different fields. Drag a connection from the primitive node and connect it to steps. Now we have control over the steps, including what happens after each generation. Instead of fixed or random, choose increment. After each run, the value increases by 1, so now we have 5 steps. If we run it again, we get 6 steps, and the image starts to change more. As more steps are added, more noise is removed, and the image becomes clearer. Next to the Run button, there is a small down arrow. From here, select Run Instant. This means we can click Run once, and it will keep running until we stop it. You can see the workflow now runs automatically. On each run, more steps are added, and the image keeps refining. You may also notice that as the number of steps increases, it becomes harder for the computer. Just like climbing many stairs, more steps mean more effort, so generation becomes slower and slower. Soon we reach around 35 steps, which is recommended for this model to get a nice, clear image, although some results already look good around 20 steps. Now we want to stop this. Click the arrow again and switch back to Run. After the current generation finishes, it will stop. There is also another way to see a small preview of what is happening inside the K-sampler. From the menu, you can go to Settings, but it is faster to access the settings from here. In the Settings search bar, type Preview. You will see an option called Live Preview Method. By default, it does not show anything. But if we set it to Auto, we can see a small preview during generation. Let's delete the primitive node, then change the seed to Random. Now, when we run the workflow, we can see a small preview of what the image might look like before it even finishes generating. Let us change the steps to 30 and run again. You can now quickly see what is happening in the diffusion process. Even though this preview is low resolution, you can clearly see how the image becomes more and more defined as noise is removed. Now let me try something more drastic. I will use a very large image size. On some computers, this might crash ComfyUI or take a very long time to generate. I will run it again with these settings. You can see that generation is now very slow, but the preview lets us observe how the image slowly starts to appear. This is a bit too slow, so I will cancel the generation here. Instead, I will try a slightly smaller image, still larger than what the model is comfortable with, just so we can see the preview updating more slowly. Now we can clearly see the diffusion process updating every few seconds. The speed of this preview is also influenced by the sampler and the scheduler. As you may remember, models are trained on specific image sizes. If a model was not trained on large images, it treats them more like multiple smaller images stitched together. For example, our Juggernaut model was trained on 512 pixel images only. Personally, I prefer not to keep the live preview enabled all the time because it can slightly slow down generation. So I will go back to settings and set the preview option back to default. I will also reset the image width and height. You may notice that the preview is still visible. This can happen because something remains in memory. To fix this, I will press F5 to refresh the browser. Keep in mind that refreshing the browser will reload only the current workflow. If you had other workflows open and did not save them, they will be lost. Now everything is back to normal without the preview. There are still more useful things to learn. This slide explains how a diffusion model is trained. This is not image generation yet. During training, the model is shown millions of images paired with text descriptions. For example, images of cats, people, objects, lighting styles, and environments. The training process uses something called forward diffusion. Forward diffusion means gradually adding noise to a clean image. At first, only a small amount of noise is added. Then more noise is added step by step. Eventually, the image becomes almost pure noise. At each step, the model is trained to predict what noise was added. In other words, it learns how images break down as noise increases. By repeating this process across millions of images, the model learns patterns. It learns what shapes look like. It learns what objects look like. It learns how lighting and structure behave. The goal of training is not to memorize images. The goal is to learn how to reverse this process later. Training a diffusion model requires massive datasets and powerful hardware. In ComfyUI, we are only using the result of that training. Now that the model has learned how noise works during training, we can use that knowledge in reverse to generate images. This slide shows the difference between training and image generation. During training, the model starts with a clean image. Noise is added step by step until the image becomes pure noise. This is called forward diffusion. This process teaches the model how images break down when noise is added. During generation, the process is reversed. We start from pure random noise. The model removes noise step by step to create an image. It is important to understand this clearly. During generation, we do not add noise like in training. We only remove noise using what the model learned before. This slide explains an important concept that is often misunderstood. The model does not store images in memory. During training, the model never saves photos that it has seen. Instead, it learns patterns and relationships. It learns what shapes look like. It learns what objects look like. It learns how parts of an image relate to each other. For example, it learns that faces usually have eyes in a certain position. It learns that animals have specific structures. It learns how lighting, shadows, and perspective usually behave. All of this knowledge is stored as probabilities inside the model. Not as pictures, but as learned rules. You can think of it like learning a language. You do not memorize every sentence you read. You learn grammar and structure. The model works the same way. It learns visual grammar, not individual images. When the model generates an image, it is not copying anything it has seen before. It is using learned patterns to guide the noise removal process. That is why results can look familiar, but are still new images. This is why changing the prompt changes the result. The prompt activates different learned patterns inside the model. That is also why the same model can generate many different images, even though it was trained only once. So far, we talked about diffusion in a simplified way, as if it happens directly on images. In reality, most modern diffusion models do not work directly on pixel images. Instead, they work in something called latent space. Pixel space is the image as we normally see it. It is made of pixels, with width, height, and color values. Latent space is a compressed representation of that image. It keeps the important structure and information, but removes unnecessary detail. You can think of latent space as a simplified version of the image that is easier for the model to work with. To move between pixel space and latent space, the model uses a VAE. VAE stands for Variational Autoencoder. The VAE has two main jobs. First, it encodes a pixel image into latent space. Second, it decodes a latent image back into pixels. During image generation, diffusion happens in latent space. After the denoising process is finished, the VAE decodes the result back into a visible image. Working in latent space makes diffusion much faster. It also uses less memory and less computing power. This is why models like Stable Diffusion can run on consumer graphics cards. Without latent space, image generation would be much slower and more expensive. In ComfyUI, this is why we see nodes like VAE encode and VAE decode. When we generate images from text, the model works in latent space, and VAE decode converts the result into pixels we can see and save. This also explains why image resolution and VAE selection can affect results. Now we look at how text prompts influence image generation. The prompt does not act only once at the beginning. During diffusion, the prompt is used at every denoising step. At each step, the model checks whether the image is moving closer to what the text describes. You can think of the prompt as guidance. It gently nudges the image in the right direction while noise is being removed. This happens repeatedly, step by step, until the final image is formed. CFG stands for Classifier Free Guidance. CFG controls how strongly the prompt influences the denoising process. With a low CFG value, the model follows the prompt loosely and allows more randomness. With a high CFG value, the model follows the prompt more strictly and forces the image to match the text more closely. Here is a quick example. You can find CFG here in the K sampler. Too low CFG can produce images that ignore the prompt. Too high CFG can produce images that look unnatural or over-sharpened. CFG is like telling the model how strict it should be about your instructions. The prompt does not generate the image by itself. The prompt only guides the noise removal process. The image is still created by diffusion in latent space. As you can see, with CFG1, the cat is still a cat, but it is not red like we asked. With CFG7, the result is much closer to the prompt. That said, this also depends on the model we are using. Smarter or better trained models tend to follow the prompt more accurately. In fact, there are some models where we intentionally use a fixed CFG value of 1, which effectively ignores the negative prompt. However, pushing CFG too high can damage the image. It can introduce artifacts or make the result look unnatural. Because of that, we always try to find a balance. The goal is to use settings that give us the quality we want in the shortest amount of time, without hurting the final image. Now we talk about seeds. Seeds are very important for understanding consistency and variation. A seed defines the starting noise used to generate an image. You can think of it as the initial random pattern the model starts from. When diffusion begins, the model always starts from noise. The seed decides exactly what that noise looks like. If you use the same prompt, the same settings, and the same seed, you will get the same image every time. If you change the seed, you change the starting noise, and the final image will be different. The prompt guides the process, but the seed decides the starting point. Different starting noise leads to different results, even when everything else stays the same. You can think of the seed like rolling a dice before starting. If you roll the same number, you start from the same situation. If you roll a different number, the outcome changes. This is a simplified explanation. The seed controls a random number generator used internally by the model. You do not need to understand the math behind it. You only need to know that seeds control repeatability.